Imagine a sunset on a planet that orbits a black hole, or one that stops, reverses, and happens twice in the same day. Consider a Martian sunset where the sky unexpectedly turns a deep, haunting blue. This is not science fiction. These are the real physics of our universe. There are 2 trillion galaxies out there, each containing billions upon trillions of stars. Our Milky Way galaxy alone is home to at least 100 billion planets. Some of these worlds orbit 2 stars, while others circle dead neutron stars or even black holes. The universe is a strange place, and the views we are about to witness are truly spectacular. So, buckle up as we travel from Mercury to the edge of the known universe. We are going to see the most beautiful and deadly alien sunsets ever imagined. Stick around to see the ultimate sunset on a planet orbiting a massive black hole. Every sunset begins with the unique composition of a world's atmosphere. On Earth, our air scatters blue light, leaving the reds and oranges for the evening. But on other worlds, the chemistry of the air changes everything we think we know about color. Some planets have no air at all, creating a stark transition from day to night. The distance from the host star also dictates how large and bright the sun appears. In the deep reaches of space, suns are mere pinpricks of light in a frozen sky. Closer to the center of a system, the star becomes a raging furnace of light. Gravity even plays a role, bending the path of light as it nears the horizon. Each world tells a story through the way it says goodbye to its star. We are starting our journey at the very heart of our own solar system. Mercury is our first stop, a scorched rock with a secret in its sky. It is a place where the sun plays tricks on the eyes of any observer. Imagine seeing the sunrise only to watch it stop and head back down. The sheer variety of these events reminds us how small our perspective really is. To understand the universe, we must look beyond our own blue sky. Why does Mars have blue sunsets while ours are red? It all comes down to the size of the dust particles floating in the air. On gas giants, there is no ground to stand on, only endless clouds. The scale of these worlds is almost impossible to comprehend. Yet even there, the sun eventually dips below the horizon of clouds. Further out, the moons of the giants offer even stranger sights. Some moons glow with their own internal light as the sun fails. We will witness the rings of Saturn casting shadows that blot out the day. In the outer edges, methane turns the sky into a turquoise dream. And finally, we will leave our solar system entirely. We will visit planets that never know a true steady sun. Worlds that are being torn apart by the very stars they orbit. Sunsets on the edge of a black hole are the final frontier of beauty. It is a journey through light, time, and the very fabric of space. Prepare yourself for the most incredible views in the known universe. We begin our journey at the scorched edge of the solar system, where the sun looms 10 times larger than it does on Earth. On Mercury, the lack of an atmosphere means there's no blue sky or orange glow to soften the transition. Instead, the sun appears as a brilliant white disk against a perfectly black velvet sky. Because of its eccentric orbit and slow rotation, the sun's path across the sky is incredibly strange. At certain locations, an observer would witness the sun start to set, then stop and rise again. This double sunset creates a dance of shadows that lasts for several Earth days. Silence reigns supreme here as the heat of the day begins to bleed away into the void. Stars emerge instantly without the interference of a twilight haze. The temperature drops hundreds of degrees in a matter of hours, turning the surface into an icy wasteland. We now leave the silent gray of Mercury for a world of crushing pressure and fire. Venus is a hellscape wrapped in an atmosphere so thick it behaves like a fluid. If you stood on the surface, you would never see the sun as a distinct circle. The air is a heavy yellow-orange fog that scatters all but the longest wavelengths of light. The weight of the atmosphere bends light so severely that the horizon appears to curve upward. At sunset, the entire sky turns a deep, bruised copper color. Thunder rumbles constantly through the thick air, though no rain ever reaches the ground. The heat is so intense that the rocks themselves seem to glow with a dull red light. There is no relief from the heat as the sun goes down because the greenhouse effect traps everything. Sunset on Venus is a slow, agonizing process that takes weeks of Earth time to complete. The darkness that follows is not a clear night, but a murky, suffocating blackness. Only the occasional flash of lightning reveals the jagged mountain peaks in the distance. This world is a reminder of how delicate the balance of light and life truly is. From the airless voids of Mercury to the crushing clouds of Venus, we see the extremes of the inner circle. We move further out, where the light begins to change in ways that defy our earthly expectations. Our next stop offers a sky that looks like a photographic negative of our own. Imagine a world where the day is red and the sunset is a ghostly blue. But before we reach the serenity of Mars, we must consider the gravity of our situation. The transition between planets is a journey through a lethal vacuum.
Light here does not scatter at all, remaining a pure and deadly stream of energy.
Without an atmosphere to shield us, the beauty of the sunset is secondary to the danger of the radiation. We push forward, leaving the inner inferno behind for the cold deserts of the fourth planet. Mars awaits with its thin air and fine dust, ready to paint a masterpiece in the sky. The scattering of light on Mars is inverse to that of Earth due to the size of the dust particles. This creates the famous blue glow around the setting sun that has captivated our rovers for years. It is a cold beauty, reflecting the freezing temperatures of the Martian night. We see ourselves in these skies, wondering if one day human eyes will watch this transition in person.
The variety of these sunsets is a testament to the diverse chemistry of our planetary neighbors.
But the solar system has far grander spectacles waiting in the outer reaches. Beyond the rocky worlds lie the giants, where sunsets take on a scale that is difficult to comprehend. Just as we grow comfortable with the blue light of Mars, a shadow larger than the Earth itself begins to loom over our path. Just as we grow comfortable with the blue light of Mars, a shadow larger than the Earth itself begins to loom over our path. We settle onto the rusted, iron-rich sands of the Gusev crater to witness a phenomenon that defies earthly intuition. During the day, the Martian sky wears a salmon-pink hue due to the suspension of fine dust in its thin atmosphere. These dust particles are incredibly small, roughly 30 times thinner than a single strand of human hair. As the sun begins its descent, the physics of light scattering undergoes a dramatic transformation. Suddenly, the area immediately surrounding the solar disk begins to glow with an eerie, cool blue light. This is known as Mie scattering, where the dust particles match the wavelength of blue light perfectly. Instead of scattering blue light away as Earth's atmosphere does, the Martian dust funnels it directly toward your eyes. For a few moments, the red planet transforms into a landscape of sapphire and indigo shadows. The sun itself appears smaller here, only about 2/3 the size of what we see from Earth. As the last sliver of blue light vanishes, we prepare to leave the rocky inner worlds behind. We ignite our thrusters and accelerate away from the gravity well of the red planet. Our destination is the king of the planets, the massive gas giant Jupiter. Entering the Jovian system is a perilous task due to the intense radiation belts surrounding the planet. Jupiter has no solid surface to land on, only an endless ocean of clouds and swirling storms. We descend into the topmost layers of the atmosphere to find a vantage point for the most rapid sunset in the solar system. Jupiter rotates at a staggering speed, completing a full day in less than 10 hours. This means that a sunset here is essentially a cinematic experience on fast forward. Looking up, the sun appears as a tiny, incredibly bright point, only 1/5 the size we see from Earth. The sky itself is a deep, dark blue, darker than any twilight ever witnessed on our home world. Because of the planet's immense size and speed, the transition from day to night happens with startling urgency. As the sun dips, the white clouds of ammonia transition into shades of deep copper and maroon. The rapid motion creates a sense of vertigo as the horizon seems to rush upward to meet the dying light. On Jupiter, you could witness 2.5 sunsets in a single 24-hour Earth day. Once the sun is gone, the Jovian night is far from empty. Immense bolts of lightning, hundreds of times more powerful than Earth's, illuminate the clouds from within. High above the massive moon, Ganymede begins to rise, its silhouette cutting a hole in the dense star field. The presence of so many moons means the sky is constantly filled with orbiting worlds and their own strange lights. We realize that to truly understand a sunset in this system, we must leave the gas giant and visit its children. Our sensors lock onto the most geologically active body in the entire solar system. Io is a volcanic hellscape, constantly being squeezed and pulled by the gravity of Jupiter and its fellow moons. As we approach, we see the sun beginning to move toward a massive, looming obstacle. Every 42 hours, the sun on Io doesn't just set, it is eclipsed by the planet it orbits. Standing on the sulfurous plains, the sun begins to slide behind the curving edge of the gas giant. This isn't a brief event like an earthly eclipse. It lasts for 2 full hours of darkness. During this time, the thin atmosphere of sulfur dioxide begins to freeze and fall to the ground like snow. The only light comes from the glowing magma rivers that snake across the frozen surface. Suddenly, we detect an even stranger light source on the neighboring moon, Europa. As the sun sets on Europa's ice-crusted world, the ground begins to shimmer with a bioluminescent-like glow. But as we turn to investigate the glowing ice, a massive surge of radiation hits our ship's sensors. Something in the Jovian magnetosphere is reacting to our presence, or perhaps we've stumbled into a storm we can't escape. The navigation systems are failing, and the glowing surface of Europa is rushing toward us at an uncontrollable speed. The emergency thrusters fire with a deafening roar as the frozen plains of Europa loom large. We skim the jagged ridges of the Connemara Chaos by a mere few hundred meters. Slowly, the automated stabilizers regain control and pull the craft back into a stable orbit. Our sensors pivot toward the inner moon Io, where a different kind of twilight awaits. On Io, the sun does not just set, it is frequently devoured by the massive silhouette of Jupiter. These frequent eclipses create a unique shadow sunset that occurs almost every day. As the sun disappears, the thin atmosphere of sulfur dioxide begins to freeze and fall as frost. The sky turns a deep, bruised purple as the light scatters through volcanic ash plumes. The temperature plummets instantly, turning the surface into a cryogenic wasteland in minutes.
Giant volcanoes like Pele continue to erupt, their fire casting long, flickering shadows into the night.
Jupiter itself hangs in the sky, a bloated, striped god reflecting sunlight back onto the moon. This Jupiter shine provides a dim golden light that replaces the absent sun. We now steer back toward Europa to investigate a phenomenon hidden from our previous flyby. As darkness falls over Europa's trailing hemisphere, the ice begins to wake up. Faint, rhythmic pulses of green and blue light start to emanate from the deep fissures. Radiation from Jupiter strikes the ice, causing a chemical reaction that glows in the dark. The entire moon becomes a bioluminescent lantern floating in the Jovian shadow. We descend once more, this time with our thermal cameras locked on the glowing vents. The camera detects movement within the liquid plumes erupting from the crust. These plumes shoot hundreds of miles into space, carrying the secrets of the subsurface ocean. The sunset here is a transition from the harsh sun to the internal warmth of the moon itself. Suddenly, a massive tectonic shift beneath the ice causes a localized quake. The probe's landing struts extend as we attempt a risky touchdown on the moving ice. The landing pads touch the surface with a metallic thud that vibrates through the hull. Far above, the shadow of Io crosses Jupiter, casting a secondary shadow onto our position. In this deep darkness, the bioluminescence of the ice becomes blindingly beautiful. We are billions of miles from home, standing on a world that glows in its own night. The spectra of the light suggest the presence of organic compounds reacting with the ice. Could this be the signature of life thriving beneath the frozen shell? The ice beneath our feet begins to crack and a geyser of superheated water erupts nearby. We must lift off before the pressure of the erupting water destroys the probe. We punch through the atmosphere of ice crystals and head toward the next Jovian giant. Jupiter looms ever larger, its great red spot a swirling vortex of ancient storms. The gravity of the gas giant pulls us toward the outer moons Ganymede and Callisto. The light here is different, filtered through the intense magnetic fields of the giant planet. We prepare for the next phase of our journey into the outer Jovian moons. Ganymede awaits us with its own unique atmospheric phenomena. The sunsets on these worlds are not just ends, but transitions to new forms of light. We check our fuel reserves as we drift further from the sun's warmth. Suddenly, a massive electromagnetic pulse from Jupiter strikes the probe's communication array. The screens flicker and go dark as we lose contact with the Earth base. We are now drifting blind toward the aurora-filled sky of Ganymede. As we descend, the sheer scale of this world becomes overwhelming. For Ganymede is a moon that rivals the size of planets.
Larger even than Mercury, this giant holds a secret deep within its core that no other moon possesses.
It generates its own magnetic field, a protective shield that battles the relentless radiation of Jupiter. This magnetic interaction creates a sunset unlike any other, where the sky itself begins to dance in invisible frequencies. As the sun nears the horizon, the Hubble telescope reveals what the naked eye cannot perceive. Great ribbons of ultraviolet auroras shimmer across the thin atmosphere, glowing with a ghostly, energetic light. To a human observer, the sky would remain black, but the sensors scream with the beauty of this hidden light show. We leave the shimmering vales of Ganymede behind and push further into the Jovian suburbs. Here lies Callisto, the most heavily cratered object in our solar system. On this distant moon, Jupiter has shrunk in the sky, looking no larger than a grapefruit held at arm's length. Because Callisto orbits so far away, the daily spectacle of an eclipse is a luxury it does not often afford. Its orbit is tilted, causing it to frequently miss the shadow cast by the gas giant. A resident here would have to wait 3 long Earth years to see the sun vanish behind the striped giant. But when the alignment finally occurs, the sky prepares for a masterpiece of geometry. The sun begins its slow descent, sliding toward the curvature of Jupiter's horizon. For 2 hours, the moon is plunged into a unique deep twilight as the light is filtered through Jupiter's upper clouds. Silence reigns over the ancient craters as the stars become piercingly bright in the absence of the sun. This rare eclipse is a reminder of the clockwork precision of the Jovian system. But even this grand scale is about to be eclipsed by something far more alien. We turn our gaze toward the ringed jewel of the solar system, Saturn. Our sensors pick up a strange, hazy signal coming from a moon shrouded in thick orange clouds. This is Titan, a world where the air is heavier than Earth's and the rain is made of methane. Here, the physics of light take a dramatic turn, scattering through a dense soup of hydrocarbons. Below the clouds, a landscape of liquid lakes and icy mountains awaits the coming twilight. The sun is a mere point of light, struggling to penetrate the thick orange haze. As the sun sets, the sky doesn't turn red, but deepens into a rich, burnt umber, and then a dark, murky brown. The liquid lakes reflect the deepening gloom, looking like mirrors of black oil under the darkening sky. But above the haze, Saturn looms a giant ghost in the sky that never truly disappears. The sheer density of the air means the sunset lasts for hours, a slow-motion transition into a cold, dark night. We rise again, leaving the orange world behind for the majesty of Saturn's rings. From the top of Saturn's clouds, the view is a symphony of light and shadow. During the day, the rings are a brilliant white arch, scattering sunlight across the hemisphere. But as the sun sets, the shadow of the planet itself begins to march across the rings. One by one, the ring sections go dark, like city lights being extinguished from above. The sun slips away, leaving only the faint reflected light of distant moons to illuminate the gas giant. It is a lonely, massive twilight that reminds us how small we are in this clockwork dance. But our journey is far from over, as the ice giants of the outer solar system call to us. A strange signal begins to interfere with our navigation, a turquoise pulse emanating from the side-spinning planet. Something is waiting for us in the methane-rich clouds of Uranus, and the sun hasn't set there in 40 years. We leave the icy moons of Jupiter behind as we approach the crown jewel of the solar system. Our first stop is Titan, a world that feels more like a planet than a moon. Titan is the only moon in the solar system with a thick atmosphere even denser than our own on Earth. As we descend lower, the surface begins to reveal its strange, alien chemistry. Below the smog, we find lakes that look like water, but are actually liquid methane and ethane. The sunset here is a slow, agonizing transformation of color. Because of the haze, the sun never truly sets as a sharp disk. Instead, the entire sky simply darkens like a room with a dimming light bulb. But the true spectacle lies back in the orbit of the gas giant itself. On Saturn, there is no solid ground to stand on to watch the sun go down. You must witness the event from the top of the ammonia clouds high above the core. The rings act like a massive, glittering mirror that dominates the heavens. As the sun begins its descent, a massive shadow begins to stretch across the rings. This is the shadow of Saturn itself cast into the very structures that orbit it. It is not just a sunset, it is the extinguishing of 1 trillion icy stars. The brilliant white ice turns to a dull, cold gray as the light leaves. Watching the rings go dark is like watching the lights of a great city being turned off. The temperature drops instantly as the thermal energy from the sun is cut off. You find yourself wishing Earth had such a magnificent structure to shade its nights. For a moment, the entire system is silent and perfectly still. But we must push further into the outer reaches of the solar system. The colors of the universe are about to change from warm oranges to cold blues. We are heading toward the ice giants where the very air behaves differently. Uranus is a planet that doesn't just orbit, it rolls on its side. This strange orientation creates the longest seasons in the solar system. At the poles of Uranus, the sun stays up for 42 years at a time. Imagine waiting 4 decades for a single sunset. When it finally happens, the sky doesn't turn red like it does on Earth. The methane in the atmosphere absorbs all the red wavelengths of light. This results in a sunset that fades into a deep electric turquoise. The beauty is chilling, reflecting the extreme sub-zero temperatures of the ice giant.
You feel a sense of isolation here that no other planet can match.
Beyond Uranus lies Neptune, a world of even deeper blues and faster winds. Here, the sun is so far away, it looks like a mere bright star. A sunset on Neptune is simply the sky turning from blue to total, absolute black.
We reach the edge of the official planets, but our journey is far from over.
Even on the tiny dwarf planet Pluto, the sunset has a ghostly charm. The moon, Charon, remains fixed in the sky, a silent witness to the fading light. But as the solar system fades behind us, we begin to wonder what lies in the deep dark. Beyond the reach of our sun, the rules of light are about to be broken by forces we cannot see. We are entering a region where the sunset isn't caused by a horizon, but by the bending of space-time itself. Something is pulling us in, and the sun we know is now 1 million light-years away. We drift further away from the golden warmth of the inner rings into a cold azure void. The silhouette of Uranus looms ahead, a giant marble of pale turquoise suspended in the dark. Unlike any other world, this giant rotates on its side, making its sunsets a geometric anomaly. As we descend into the upper atmosphere, the methane gas begins to filter the fading sunlight. The sun appears as a tiny, brilliant needlepoint of light against a vast cyan sky. There is no solid ground here, only a gradual thickening of the cold, misty air. The twilight on Uranus lasts for years in some regions due to its extreme axial tilt. We leave the tilted giant behind and accelerate toward the sapphire depths of Neptune. Neptune greets us with a much deeper, more intense blue born of a violent atmosphere. Supersonic winds whip through the clouds, creating a turbulent canvas for the setting sun. The sun is now so small, it can no longer illuminate the entire horizon at once. It looks like a bright star rather than the roaring furnace we knew on Earth. The blue light fades into a heavy, oppressive indigo as night falls over the great dark spot. Our sensors lock onto a small, icy speck at the very edge of the sun's gravitational domain. Pluto awaits a frozen world of nitrogen ice and dark red mountains. The temperature here is a staggering 200 degrees below zero.
We land on the edge of the Sputnik Planitia, the vast ice plain that serves as Pluto's heart.
A thin haze of blue nitrogen atmosphere clings to the horizon like a ghostly veil. The sun begins its slow descent behind the jagged water-ice mountains of Cthulhu Macula. It provides as much warmth as a flashlight in a dark cathedral. As the sun dips lower, the blue haze becomes more pronounced, scattering what little light remains. The landscape turns a deep, bruised purple as the long shadows of the mountains stretch for miles. Looking up, we see Charon, Pluto's massive moon, hanging motionless in the sky. It doesn't rise or set, it simply watches over the frozen world in eternal silence. The sunset here marks the beginning of a night that will last for Earth weeks. We stand at the edge of the known, where the sun is just another star among billions. But our journey does not end at the borders of our own star system. We must push further into the realm where light behaves in ways that defy imagination. We are leaving the comfort of the familiar behind for the exotic and the terrifying. Deep in the heart of distant nebulae, stars are born and die in a cycle of fire. We detect a signal from a system orbiting a dying star. The gravity here is warping the very fabric of time and light. The sun in this system is not a sphere, but a crushed, spinning diamond of light. Every sunset here happens in a fraction of a second. We are approaching the final frontier of the cosmic light show. Beyond the stars lies a darkness that consumes light itself. The horizon here is not a line on a planet, but the edge of existence. Our navigation systems are failing as we get closer to the center. We try to turn back, but the pull is too strong for the engines to overcome. The last sliver of the universe's light is being swallowed by a shadow larger than 1 billion suns. Beyond the edge of our familiar sun's reach, the universe reveals horizons that defy human imagination. We begin our final descent into the realm of exotic stars, where light itself behaves like a flickering ghost. Orbiting a pulsar, a lonely world witnesses a sunset composed of deadly gamma rays and violet lightning. Every few milliseconds, the horizon erupts in a blinding flash that paints the rocks in neon hues. We transition now to a planet orbiting a white dwarf, the cooling ember of a once great sun. Here, the sunset is a slow silver fade into a permanent diamond-clear night. The atmosphere of this dying system is so thin that the stars are visible even as the sun sets. As we push further into the galactic core, the gravity of giant monsters begins to warp the very fabric of light. We approach a rogue planet caught in the gravitational grip of a supermassive black hole. On this world, the sunset does not involve a star, but the glowing ring of a gravitational predator. Light is bent into impossible circles, creating multiple ghostly images of the horizon in the sky. The sun here is a thin line of fire that stretches across the entire sky as it is swallowed by the void. This is the ultimate end for light, where every photon is reclaimed by the darkness of the abyss. Throughout our journey, we have seen that every world has a unique way of saying goodbye to the day. From the boiling clouds of Venus to the frozen rings of Saturn, light is the artist of the cosmos. We have traveled billions of miles to realize that the beauty of a sunset is universal. Even in the coldest reaches of the void, the dance of photons continues to tell a story of energy and life. We return finally to our home, seeing our own familiar sunset with new cosmic eyes. The golden light of our sun warms the clouds of Earth one last time before the stars take their place. The shadows of our trees and mountains grow long, connecting us to the rocky reaches of Mercury and Mars. Our journey through the cosmic twilights has shown us that darkness is merely the stage for light's greatest performance. Every sunset we witnessed was a reminder of the delicate physics that allow us to exist. The universe is a vast gallery of light, and we are its fortunate spectators. As one sun sets, billions more are rising across the countless worlds of the Milky Way. The cycle of light and shadow remains the heartbeat of the cosmos. We have solved the mysteries of the blue Martian dusk and the gold-ringed black hole. But the greatest mystery remains the sense of wonder we feel when the light begins to fade. No matter where you stand in the universe, the sunset is a bridge between the day's toil and the night's dreams. The shadow that once seemed so large has now become a canvas for the stars. Our exploration concludes here in the quiet embrace of the infinite night. May you always find beauty in the moments when the light begins to change. The universe is quiet now, its grandest spectacles having been witnessed and recorded. We are all made of star stuff, and to the stars we shall always return. As we fade to black, remember that every end is just a new beginning in another corner of the sky. The light of knowledge will continue to shine even when the stars go out. Rest now, for the cosmos is at peace and its twilights are eternal. We have seen the double suns and the violet flares. We have felt the chill of the blue Martian winds. And we have stood before the majesty of the black hole's fire. Our journey is complete, and the universe is yours to explore.